Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a locus problem with complex numbers. So we have the argument of z plus 1 all over z equals pi over 2, and we're going to be finding the values of z which satisfy this type of equation. That's why we call these locus problems. So there's going to be probably more than one solution, maybe in some cases no solution or infinitely many solutions. So basically, we're looking for z values that make this equation true. So let's go ahead and see how we can do this. We have the argument of a quotient. So what is z plus 1 over z look like, right? What is that going to look like? Well, you can go ahead and do a couple different things here. First of all, which is a very common method, by the way, you can replace z with x plus yi. And of course, z plus 1 is just going to be x plus 1 plus yi. So I wanted to separate the real and imaginary parts. Let's go ahead and plug it in. Argument of z plus 1, which is x plus 1 plus yi, divided by x plus yi is equal to pi over 2. Now, what does it mean for a complex number to have an argument of pi over 2? If you think about the complex plane or the argand plane, where we have the imaginary axis here and the real axis here, pi over 2 means that our number is purely imaginary, right? So it's located something here, like somewhere here. So that's going to be our argument. Okay, we don't know anything about the absolute value and we don't care. The only thing that matters in this case is the relationship between x and y. So let's go ahead and simplify this a little bit. I'm going to start with this and multiply it by the complex conjugate, which is x minus yi over x minus yi. We're going to go ahead and distribute and simplify this. Here we need to multiply the real parts, x squared plus x. And then, of course, this is going to give us plus y squared, right? And then we're going to multiply x plus 1 by y. So let's go ahead and take the I out. That's going to be y times x, so yx. And then x plus 1 is going to be multiplied by y. All right? And the whole thing is divided by x squared plus y squared. That's the expression inside the parentheses. We want the argument of this number to be pi over 2. Let's go ahead and simplify this a little bit more. Obviously, here yx cancels out. We end up with x squared plus y squared plus x plus I times negative y divided by x squared plus y squared. And let's go ahead and split it into two pieces. Since we want to look at the real and imaginary parts separately, we're going to divide this by x squared plus y squared, and then minus I multiplied by y over x squared plus y squared. Now, how can the argument of this number can be I? So we have a complex number whose argument is I. It has to be imaginary, right? Which means we do need this to be 0. Why? There should be no real part. Easy, right? And that means x squared plus y squared plus x is equal to 0. That's not the only condition you need. You also want the imaginary part to be greater than 0. Now what we notice here when we multiply by x minus yi, we basically did get the product of xy, and then we did get the product of these two things, which is minus xy minus y. So we did get a minus yi here, which means this expression needs to be positive. But of course, there's a minus sign, which means this needs to be negative. Okay? All right. Otherwise, your argument is going to be negative pi over 2 instead of pi over 2. Great. So let's go ahead and see what this quadratic equation means. Well, we can try completing the square here. X squared plus x with y squared equals 0. We're going to go ahead and add 1/4 to both sides, right? That's the mathematical number that makes this a sum of two squares. This expression right here is x plus 1/2 quantity squared plus y squared is equal to 1/4. Great. Now, what does this mean? This just means that we have a circle. What kind of circle are we talking about? Well, we have a circle whose center is at -1/2, comma 0, right? From here, hopefully, you do recognize the equation of a circle in the coordinate system. And obviously, the radius is 1/2. So basically looking at -1/2, let's just say this is -1/2, and then 1 is going to be like twice, kind of scale it up. And then, of course, the y-coordinate is 0, so our center is right here, and the radius is 1/2, which means our circle is actually going to touch the y-axis, or it is tangent to the y-axis, right? Great. Now, what are we going to do with this, right? Well, it's not the full circle. Why? Because remember, we said something about y being negative. Obviously, this is always a positive quantity, right? And x equals 0, y equals 0 will give you 0, but z equals 0 obviously is not going to satisfy this. As you know, it's going to make it undefined. So we kind of have to exclude x equals 0, which means this point is not included, okay? You can exclude it, but not just that. We are only going to be taking the bottom part, and let's see if we can do this here. Let me pick a different color. So we are looking for a semicircle here. Of course, this is not included. And let's see if I can erase the top part. Okay, with a partial eraser, I should be able to do that. Here we go. And yes, the solution is going to be the bottom half of our circle. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.